Hello, and welcome to one of my C++ tutorials. So, if you like my video so far, please remember to hit that like button, subscribe to my channel, and share this video far and wide. So, what we're going to be doing is I'm going to be introducing you to nested if statements. So, what task are we going to do today? Well, the first things first, good news is we got some code we can copy. So, we're going to copy this program into Replit. It's just plain old copy and paste. So, this is an example of good working code. So the pedagogical approach I'm taking with this task is PRIMS, which is predict, run, investigate, modify, and make. So the first we need to do is predict what the code will do when you run it. So I predict it's going to ask us to enter our age, and then if we enter our age, it's going to go. If it meets certain conditions, it's going to go and produce the following cout. So if I enter like 17, it's going to say I should be in school. If it's over 17 and under 65, it's going to say I should be in work. Else, I can retire. So let's run it. So I'm going to make that prediction. I am 15. Should be in school learning, not on our Xboxes. Age, I'm going to say 18. I should be in a job because it's not met the condition of it being under 18. So as it's over 18, it's going to go into the else, and it's going to find, okay, we know it's not over 18, not under 18. Is it under 65? Yes, it is. So hence, you should be in a bloody job. Let's say I was to type in the word 65, however. We know it's over 18. So let's go on the else. Okay, is it over 65? Is it under 65? No, it's not. I can retire. Oh, I could put my feet up. I could see if I could do well on countdown, etc., etc. All have a Zimmer frame, stereotypical, by the way. Okay, never mind that. So we've done a predict, and we've ran the code. Okay, so my prediction was correct. So the program is using a nested if statement. So that means there's an if-else statement within an if statement. So the nesting's taken place with the else. Okay? So that's it. So it's taking place with the else. So, what is the less than operator used for? The less than operator determines the number, any number being less than what number we decide to hard code. So in this case, if its number is less than 18, it's going to say it should be in school. If it's over 18, but less than 65, then that's when we should be in a bloody job. So now we need to modify the program so it works exactly the same, but we're using elif statements rather than the nested if statement. So what we can do else if age is greater than or equal to 18, and so shift ampersand twice, age is less than 65. So we can just produce this little cout here, that we should be in a job. Otherwise, we can retire. So let's give this a go, shall we? So a nice quick way of modifying. So enter my age. I'm going to say I am 16, more motivated. Let's run it. I'm going to say I am 24, should be in a job. 18, should be in a job. 64, let's type 65. You can retire. So we have completed the modifier. We've modified the program successfully. Now, this is where it gets difficult. We need to make a new program that will find the largest of three numbers. Now that is going to be a challenge in on itself. So, what we will need to do, I would normally encourage my students to make a new replit, just so they learn the skill. But I'm not going to do that in this case. I'm going to use the one that we have. So rather than making the video take a little bit too long, I can just get the code down for you as much as we can. So we need to make a new program that finds the largest of three numbers. So first, we will need three integer variables declared and their cins and couts. So this is where we need loads of nesting. So we got if. So all it is just a series of ifs and else ifs. So if n1 is less than or greater than or equal to n2, and n1 is greater than or equal to n3, then we're just going to say the largest number. If n2 is greater than or equal to n1, and n2 is greater than or equal to n3, then we say the largest number is n2. Otherwise, it's going to be n3. So let's test this, and let's see that actually work. And it'd be more helpful if I actually spelt number properly. So enter a number. I'm going to say 42, 24, 33, 76. Largest number 76 because because 33 is larger than 24, but 33 is not larger than 76, so hence it goes into else. So I'm going to do 76, 33, 24. Largest is still 76. So n1 is larger than n2, n1 is larger than n3, so it's going in the first one. Let's try 76, 24, 33. Let's try 76, 24, 33. So n2 is not larger than n1, but n2 is not larger than n3. So let's try it. So I'm going to try. So n1, I'm going to make that as 33. And then n2, I'm going to make that 45. So we know that n2 is larger than n1. And I'm going to do 34. So n2 is also larger than n3. So the largest is 45. So hence it's n2. Okay? So that is the entire task using the PRIMS pedagogy process when it comes to a good example of good working code. Okay, let's go on to the next program where it's involving nested if statements. So this is where we will need a string variable because we're going to ask the user if it's raining. If they answer yes, ask if it's windy. If they answer yes again, say it's too windy for an umbrella. Otherwise, we display take an umbrella. If it's not raining, ask if it's sunny. If it is, we say put on sunscreen. Otherwise, we say have a nice day. How are we going to do this? Well, first, let's do include string. Otherwise, we're not going to be able to have a string. So, we can have string. So we can have a string called raining, windy, sunny. We've got three strings there. So we're going to see out and say, is it raining today? Let's clear that one. and then we're going to cin raining. Remember, double chevrons, not singles. So now we're going to do if raining is equal to yes. And let's have a bit of fun with this. So space, we could do shift backslash twice, or raining is equal to yes, or raining is equal to yes. So what we are going to do there is we are going to ask we're going to do cout, is it windy? And if it is, we're going to ask if it's windy. And if it is, then we're going to say it's too windy for an umbrella. Otherwise, we're going to say take an umbrella. That's that part done. And then we're going to do else, because it's saying if it's not raining. So then we're going to cout, is it sunny? Is it sunny today? And then we're going to cin sunny. Okay, what else are we going to do there? If sunny has got all these yeses in there, then we are going to cout, put some sunscreen. And then if not, we're going to cout, have a nice day. End line. So let's have a look, shall we? Let's give it a couple of tests. Is it raining today? No. Is it sunny today? Yes. Put on sunscreen. Raining today? No. Yes. No, no. Right. I'm going to say yes. 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 No. Yes. Yes. Yes, and so on. So we've tried to test every single outcome there. Every single possible outcome that we've programmed ourselves. And that is the first two tasks where we've done 3 programs in this one. If you've enjoyed this video, please remember to click that like button and subscribe to my channel and share this video far and wide. And I look forward to making the next video for you shortly. Thank you very much, and goodbye for now.